Welcome back, everybody. In this video, I'm going to continue talking about logarithmic functions, but more specifically, properties of natural logarithmic functions. Before I begin, the graph e to the power of x has a one-to-one function, e to the power of x. So we have e to the power of x has a one-to-one function and therefore has a special inverse called the natural logarithmic function, which is denoted by the symbol ln of x. So y is equal to ln of x. We say natural log of x. Throughout this video, we're going to use the log of x and the natural log of x interchangeably. And the relationship between them exists right here. So let's say if I have a function, let's say g of x is equal to the log base e of x. Now this function right here is equal to the natural log of x. This is the relationship between them. If I get the log base e, I'm going to get the natural log of x, where x cannot be less than 0, or x cannot be a negative. You cannot get the negative, you cannot get the log of a negative number or the natural log of a negative number. Pretty important concepts to keep in mind. Let's go ahead and look at the properties of natural logarithms first before we go ahead and look at our problems here. We have the natural log of 1 is going to give us 0. Just like the log, just like how the log has a base b, think that the natural log ln has a base e somewhere here between ln and 1. So basically I'm saying that e to the power of 0 is going to give us 1, which is correct. Well, anything to the power of 0 is going to give you 1. However, it's good to know. It's good to keep that in mind, just so that you can avoid confusion. In our second property here, we have the natural log of e is equal to 1, which is logically correct, yes, because e to the power of 1 is going to give you e. We have the natural log of e to the power of x. We already said that the natural log of e is just 1. So since this is 1, x is just going to drop down here, and that's going to give us x is equal to x, which is correct. In our fourth property here, we have if ln of x is equal to ln of y, then x is equal to y, which is what it says right here. Now let's look at a couple of examples. We have ln of x. I'm going to leave this here for reference, so let me leave it at the top right here. We have ln of x is equal to negative 5. Now how can we solve this? One thing we can do is that we can raise ln of x, we can put an e here and raise it to the power of ln of x. And then, because we did this to one side, we have to do it to the other side as well. Since we have the same base, since e to the power of ln of x is just going to give us x, which is what it says right here, x can just drop down. This whole term just goes away. And then we're left with e to the power of negative 5, which is just a constant. You can just leave your answer like this or put it in a calculator. Our second problem, we have e to the power of x is equal to 3. Now what we can do here is that we can attack the natural log on both sides. We get the natural log of e to the power of x and the natural log of 3. The natural log of e to the power of x is just x. This whole term goes away. Then we're left with the natural log of 3 on one side, which is also a constant that you can put in your calculator. And that's just going to spit out some value. Now let's do a slightly more difficult problem here. We have half times 3 to the power of x equals 22. Now, since I can't multiply half by 3 to the power of x, just because I don't know what the value of the power is here, we can get rid of the half on this side by multiplying it by 2. And then we have to multiply it here by 2 as well. We're going to end up with 3 to the power of x on the left side. Then we're going to end up with 44 on the right side. Now, since I have 3 to the power of x, what I can do here is that I can attack a log using property 3. I can attack a log with base 3, and that's going to help me get rid of the 3 here, and then we're going to end up with x. So basically, we can say log base 3 of 3 to the power of x is equal to log base 3 as well, 44. Now, since b is equal to b, 3 is equal to 3, that's just going to give us x. So I'm left with x here. And these terms go away. Then we're left with log base 3 of 44. Now you can leave your answer like this, or you can. Remember how I said we're going to be using logarithms and natural logarithms interchangeably. One thing you can do here is that you can take the natural log of 44 over the natural log of 3. And that's going to give you the same answer as this one right here. Let me do 2 more problems. Here we have 4 to the power of x squared minus 3x is equal to 256. Now, since I have a constant here, what we can try to do is that we can try as much as we can to come up with a number, specifically 4, so that the bases are the same, but the powers are different. If we end up having the same base, we can equate the powers, and then we can finally solve for x. So what we can do here is that we can think of what number must I multiply 4 by itself to get 256? Or excuse me, how many times do I need to multiply 4 by itself to achieve 256? Now I know that 4 times 4 is going to give us 16. And then 16 times 4 is going to give us 64. If I multiply 4 again, we get 64 times 4. 4 times 4 is 16. 4 times 6 is 24. Plus 1 is 25. So I need to multiply 4 by itself 4 times to get 256. And by doing this, we have changed the base, made the base equal, changed it from 256 to 4. Now, since the bases are the same, everything is smooth from there. So x squared minus 3x is equal to 4. we ended up here with a polynomial. So x squared minus 3x minus 4 is going to give us 0. Now what two numbers can I multiply? That's going to give me negative 4, and if I add, they're going to give me negative 1. Now obviously I can think of 1 and 4 because, well, if you multiply them, you're going to get a 4, and if you subtract, you're going to get 3. But we want two numbers that if we multiply, we get negative 4, and if we add, we get negative 3. So I can think of negative 4 and positive 1, because negative 4 times positive 1 is negative 4, and negative 4 plus 1 is going to give us a negative 3. So you can confirm this if you want using the FOIL method, but I won't go ahead and do that. But our answer eventually is x equals negative 1 and x equals positive 4. Those are our two answers. Let me go ahead and do one more problem. Here we have 4 times 6 to the power of 2x minus 1 minus 3 is equal to 12. Now first things first, let's clean up what we can. We have negative 3 here. If we move it to the other side, it's going to be positive 3. So 4 times 6 to the power of 2x minus 1 is equal to 15, right? Okay, now we have 4 attached to 6 to the power of 2x minus 1. We can divide by 4 on each side. It's going to get rid of the 4's here. We're going to end up with 6 to the power of 2x minus 1 is equal to 15 over 4. Now, so since we can't really make this the same base, what we can do, however, is that we can use one of our logarithmic properties. We can attack a log base 6. Well, let me try to move this a little bit. We can attack a log base 6 of 6 to the power of 2x minus 1. That means is that we can eventually get rid of the 6 here, and that we're left with 2x minus 1 at the bottom. Now the bases need to be the same, so log 6 of 15 over 4. Now since the base is the same, this is all going to cancel. We're going to end up with 2x minus 1 is equal to log 6, 15 over 4. Now we can move this 1 to the other side and end up with 2x is equal to log base 6. 1 oh, this is correct, excuse me. The 1 over here in standard form is usually better if we put the constant in front. Just so that it looks cleaner, like that. And then we have 2 next to the x. What we can do is that we can just divide by 2 on each side. We're going to end up with x is equal to 1 plus the log base 6 of 15 over 4, all this over 2. And that's our answer. Thanks everybody for watching. If you have any questions or concerns, please don't hesitate to leave a comment in the comment section below. I'll make sure to look at them. Please don't forget to like this video, subscribe to my channel. This is going to help grow the channel more. And we'll see you in the next video.